Hey guys, this is Carrie, and this is the answer key video for homework number 2. So we're going to be classifying these functions just like we've been doing in class. So it looks like, to start off, we've got a function that has, worrying about degree first, even degree because the arrows are facing the same way. So the next question is this an even function or an odd function? It actually turns out to be neither. To be an even function, it has to be perfectly symmetric across the y-axis, so something like this. And to be an odd function, it has to be perfectly rotational symmetry around the origin 180 degrees. So this is neither for the function type. This one, the arrows are facing the same way, so it's even degree. In addition to this, it has perfect symmetry across the y-axis. That makes it an even function. The next one, the arrows are facing opposite ways, so this is an odd function, or an odd degree, sorry. To check if it's an odd function, it needs to have that extra symmetry. If you rotate it about the origin, it does not end up being exactly equal to itself. It ends up shifting. So this is actually neither function. For the next one, the arrows are facing opposite ways. That means it's odd degree. And if you take this piece and you rotate it 180 degrees, it will exactly land on the other side. So this is in addition to being odd degree, an odd function as well. Alright, time to focus on the main part of today's lesson. So the main part of today's lesson had these interesting distribution problems where you had to fill in the coefficients. So fill in the blank so that the following equation is true. When you're done filling the blank, prove that your answer is correct. The way we're going to prove that it's correct is we're going to show that these two sides are actually equal. So here we go. X times this has to give us 4x cubed. That means we need a 4 here because x times x squared gives us the x cubed. 1 times 4 gives us the 4x cubed. So these match. One thing that we talked about in class today was usually when we distribute, you go like this and then like this. But actually, for these problems, it's easier to, rather than distribute the x to all of them, just switch between the x and the 3. So next I'm going to distribute the 3 to this one. That will give us 12x squared. And you might be thinking, oh man, this is a problem, because we actually wanted 9x squared. So in order to get 9x squared, what we have to realize is that x times the next term, that actually is also going to give us an x squared term, so we get negative 3x squared here. Together those make 9x squared, so we're done here. Next we do 3 times the negative 3x, always switching between the x and the 3. So 3 times negative 3x is negative 9x. Now we switch back to the x times 2 is 2x. Together those make negative 7x, which is wonderful, because that's what we wanted. And then lastly, we have to switch back. We've done the x last, so now we need to do 3 times 2, which is 6. And that's very lucky, because we wanted to end with 6. So if we have a 4 here, this is equivalent to this. And so we've proven that it must be a 4. Next up, fill in the blank, so the following equation is true. We're going to do this in the exact same way. So we start with x, we get 3x cubed, which is great. Now we're going to switch back and forth from x to 2. So we'll do the 2 next. That gives us 6x squared. X times 2x is 2x squared. And together, these give us 8x squared, which is great because that's what we wanted. Next, we do 2 times 2x because we're switching back and forth. That gives us 4x. Since we just did 2 times 2x, the next one that we're going to do is x times the blank. When we do x times the blank, we have to think ahead. So we have 4x currently, but we actually want 9x. So to get 9x, it looks like we need an extra 5x, so we probably have a plus 5 here, because 5 times x is 5x. And then switching to the 2 times 5 is 10. And that's great, because 9x matches 9x, 10 matches 10, so everything is good. Alright, for this one, I'm going to try to switch less colors because I think it might be distracting. And actually, I'm going to skip problem 4, leave that one for you guys to figure out, and I'll do the harder one, problem 5. So for problem 5, everything is missing. So now let's see what we need to do. X times blank x squared gives us 2x cubed. That means this must be a 2. That gives us 2x cubed. That's wonderful. We're going to switch between x and 3. That gives us 6x squared. But we don't want 6x squared. We actually want 3x squared. So x times the next one has to complete that. We need a negative 3 here. So that gives us negative 3x squared. That will give us 3x squared when we combine it. We're going to switch from x to 3, so that gives us negative 9x. But we don't want negative 9x, we want negative 5x. In order to get negative 5x, x times this next one must give us the remaining piece. It looks like we want plus 4x here, so we want plus 4 here. And then 3 times 4 is 12. But we don't want 12, we want 7. So since 3 times 4 is the last of the distribution, we require an extra term out here to adjust things. And that extra term, let's see, well, we want 7, so it looks like that extra term is going to be negative 5, so that we get 12 minus 5 equals 7. So now that we've got all the blanks filled in, it looks like we're good to go. For the last problem here, it says, is the following equality true or false? So when you want to prove an equality is true or false, it's similar to the process above, where you check to make sure that both sides of the equal sign are the same. So again, we're going to check to see if both sides of this equal sign are the same, because we're going to do a lot of distribution. So we got the left-hand side and the right-hand side. So starting with the left side, we've got x squared minus 4 squared minus 5 times x squared minus 4 minus 6. When we square something, it means that thing times itself. For this one, we're going to be distributing the minus 5. That gives us negative 5x squared. That gives us plus 20 minus 6. X squared times x squared, we add the exponents. X squared times negative 4 is negative 4x squared. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 4 is positive 16. Minus 5x squared from here. 20 minus 6, combining like terms, that gives us 14. Combining some more like terms, let's see. That's going to give us x to the 4th minus 13x squared plus 16 plus 14, that's going to give us plus 30. All right, so if the right-hand side is equivalent to this, then this will be a true equality. Let's check. So we're going to check the right-hand side. Maybe I'll change the color to purple. The right-hand side is this, so I'll rewrite it. X squared minus 7 times x squared minus 6. X squared times x squared, you add the exponents. X to the 4th. X squared times negative 6 is negative 6x squared. Negative 7 times x squared is negative 7x squared. Negative 7 times negative 6 is plus 42. We can combine like terms. We get x to the 4th minus 13x squared plus 42. So now the thing that we're checking is, are these equal to each other? And they are mostly, but 30 and 42 are different numbers, so these are not equal to each other. This is false. Alright guys, that's the end of the homework video. I'll see you in class tomorrow. Hope this was helpful. Bye.